This is gonna be a really short video, but I wanted to keep the concept of impulse as a separate video from the video where we discussed momentum. So let us start. So impulse is, I guess, the title of this video. So recall that force is given by the change in momentum with respect to time. This is the alternative form of Newton's second law that we studied in the previous video, which means that delta P is equal to force times delta T. Now define a new quantity called I, impulse, which is a vector quantity, equal to force times delta T, which is also equal to delta P by the definition, measured in newtons times seconds, just like momentum. So what is this quantity now? So impulse expresses how much force, again my handwriting, so how much force we must exert on an object to remove all of its momentum, or alternatively, for how long we must exert a force in order to remove all momentum. So the usual example that comes up in 1-point questions, so the multiple choice part of the A-level exam, is a ball hitting a wall. So let's do example ball hitting a wall. So let's say that we have a ball of mass m moving with velocity v to the right, and it hits a stationary wall. So here is what happens, and it returns back with some velocity minus v, and the minus stands for the change in direction because now we move in the negative side of the x-axis. So what is the change of momentum of the ball? So I is, as we said, delta P, which is defined as P final minus P initial. Now P final is minus mass times V because this is the final momentum, then minus the initial momentum, which is simply mass times V because initially the object moves to the right. So the change in momentum is minus 2mv, which is the impulse on the ball. So the impulse on the ball is minus 2mv. Sometimes they ask, what's the impulse on the wall? The impulse on the wall is going to be the opposite of what the impulse on the ball is, so plus 2mv. Okay, so the impulse on the wall is plus 2mv. And the final thing I want to mention regarding impulse is that we can, if we plot, we can make a graph for impulse. So if we plot force versus time, then the area under the curve is impulse. So this is the, if this is the force in newtons and this is time in seconds, and let's say that the force has some weird shape like this, then this area under the curve, this is impulse. And in the occasion when they ask you to calculate the impulse from a graph like this, all you have to do is to count how many squares there are under the graph. I know it's going to be brutal, but you take this as one square and then you calculate how many full squares there are in here. So in this example, let me see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have 130, and then plus we can fit about I don't know, we can count this as 1, and then maybe 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and you get the idea. So you have to count all the squares and approximate how many squares there are in corners and weird shapes like that. Okay, so if I had to take a wild guess, this would be about maybe 150 squares, and then whatever the units are they give you will give you the final result. So this is it for impulses.